US just revealed a supersonic jet so advanced it makes everything before it look ancient. The XB-1 isn't just fast, it breaks the sound barrier and disappears before you even know it was there. Forget stealth bombers and Cold War tech. This is something straight out of the future. It's real, it's flying, and it's about to change the world of aviation forever. The XB-1, also nicknamed the Baby Boom, is not merely another test aircraft, it's the first independently developed supersonic jet in decades, brought to life by Boom Supersonic. This aircraft symbolizes the rebirth of supersonic aviation for commercial and potentially military use. While the Concorde was retired in 2003, many believe supersonic flight had ended. But now the XB-1 is taking to the skies, promising a new era where Mach speeds are not only possible, but sustainable, safe, and efficient. What makes the XB-1 even more exciting is its potential role beyond just a technology demonstrator. While its primary purpose is to test technologies for Boom's upcoming Overture airliner, the capabilities being packed into this small frame are grabbing the attention of aviation experts, the US military, and aerospace giants alike. It might be small, but the XB-1 carries the weight of the future on its wings. In this deep dive, we'll uncover the XB-1's design innovations, its jaw-dropping performance, the technology behind its stealth and speed, how it compares to other jets, and what it means for the future of both civilian and military aviation, design and engineering. The XB-1 is a marvel of modern aeronautical engineering. At just over 71 feet long, with a wingspan of 21 feet, this sleek, needle-like aircraft is optimized for minimal drag and maximum efficiency. Its carbon composite fuselage reduces weight while enhancing strength, allowing it to slice through the air at speeds exceeding Mach 1.7. The aircraft is equipped with a delta wing configuration and canards for stability at high speeds. Design choices inspired by military jets like the F-16 and SR-71 Blackbird. Every angle, every curve on the XB-1 has been shaped by thousands of hours in computational fluid dynamics, simulations, and wind tunnel tests to maximize aerodynamic performance. What's most surprising is how the XB-1 achieves this without relying on afterburners, which are fuel-intensive and loud. Instead, it uses three General Electric J85-15 turbojet engines, modified versions of the same engines used in military aircraft like the T-38 Talon. This allows the XB-1 to maintain supersonic speed more efficiently and with fewer emissions, setting it apart from its supersonic predecessors. Supersonic speed and performance. The XB-1 is designed to cruise comfortably at Mach 1.7, nearly 1,300 miles per hour. That's over twice the speed of today's fastest commercial airliners. At this speed, New York to London becomes a 3.5-hour trip instead of 7. And in military terms, that's enough to respond to threats or reach distant theaters of conflict in record time. One of the key challenges in achieving and maintaining supersonic speeds is shockwave management. Boom's engineers address this by optimizing the XB-1's nose cone, wing angles, and inlet designs to reduce the effects of sonic booms. This innovation is crucial if supersonic travel is to return to populated air routes. The XB-1's performance is not just about raw speed, it's also about agility, responsiveness, and control at high velocity. Unlike the Concorde, which was powerful but stiff, the XB-1 has been engineered for smooth handling and stability even as it breaks the sound barrier. This makes it ideal not just as a test bed, but potentially as a next-gen military platform. Avionics and Cockpit technology. Inside the XB-1, the cockpit is built like something from a futuristic fighter jet. The pilot sits in front of a fully digital fly-by-wire system with touchscreen interfaces and real-time telemetry displays. All systems are monitored through a streamlined glass cockpit, eliminating the clutter of analog dials and gauges. One notable feature is the forward vision system, which uses cameras to give the pilot a precise view ahead during takeoff and landing, a necessary innovation because of the aircraft's long, pointed nose. This system ensures safety while preserving the aerodynamically optimal design. Additionally, the flight control software continuously makes micro adjustments to the control surfaces, allowing the XB-1 to maintain stability even in turbulent supersonic airflow. This makes the aircraft safer and more reliable, even when flying faster than sound. Fuel efficiency and environmental impact. One of the major criticisms of supersonic flight has always been fuel burn, but the XB-1 is tackling this head-on. Boom's Supersonic is committed to making its jets run on 100% sustainable aviation fuel, SAF. This drastically reduces the aircraft's carbon footprint and shows that high speed doesn't have to mean high pollution. Compared to the Concorde, which was infamous for its fuel consumption, the XB-1 is 30% more efficient in its class. The careful selection of engines, materials, and aerodynamic shaping ensures that fuel usage is optimized at every stage of the flight. Moreover, the XB-1's operational data will help design the Boom Overture airliner to be both faster and greener. If successful, this would be a giant leap not only for aviation technology, but for climate-conscious innovation in aerospace. The XB-1 rolled out in 2020. It's been undergoing rigorous ground testing. From engine runs to taxi tests and high-speed runway trials, the aircraft is being put through the ringer to ensure every system functions perfectly under real-world conditions. Flight testing is being conducted in the Mojave Desert, an iconic location for experimental aircraft. Boom has partnered with the U.S. Air Force's AFW-ERX program, which provides both technical support and airspace access. This collaboration could lead to defense applications down the road. As of now, the XB-1 is progressing through phased test flights, gradually increasing altitude and speed. If these tests succeed, they'll pave the way for the Overture Boom's commercial airliner, designed to carry 65 to 88 passengers at Mach 1.7 by the end of the decade. Military implications. More than just civilian use, while Boom Supersonic's official line is that the XB-1 is a technology demonstrator for commercial aircraft, the U.S. military is watching closely. The speed, efficiency, and low boom design could make this platform a contender for rapid response recon or next-gen transport missions. The Air Force is particularly interested in how technologies from the XB-1 could be applied to next-generation stealth drones or executive transport. In contested airspace, an aircraft that can outpace radar detection and reach high-value zones in minutes is a powerful asset. With minimal redesign, it's not far-fetched to imagine a future where variants of this aircraft support surveillance, electronic warfare, or even unmanned missions, all at supersonic speeds. Comparison with past and present jets. So how does the XB-1 stack up against legends like the Concorde or the SR-71 Blackbird? Surprisingly well. While the Concorde was faster on paper, it was louder, less efficient, and not environmentally sustainable. The SR-71, though a marvel, was built with 1960s tech and couldn't be operated economically today. Modern jets like the F-22 and F-35 are multi-role fighters with stealth and combat capabilities, but they're not designed for sustained civilian supersonic travel. The XB-1 fills a niche that has long been empty. Fast, efficient, and safe non-combat supersonic flight that could be scaled up for broader use. Even compared to experimental jets like NASA's X-59 QSST, the XB-1 holds its ground. Both are testing low-boom technology, but the XB-1 is already flight-ready and based on production-grade systems, giving it an edge in real-world deployment. Public reception and industry buzz. Since its unveiling, the XB-1 has captured the imagination of both the public and the aerospace industry. Aviation enthusiasts see it as the long-awaited successor to the Concorde. Tech analysts consider it a bold move in a time when commercial aviation has stagnated in speed. Investors and policymakers are taking notice too. Boom Supersonic has already signed partnerships with major players like United Airlines and the U.S. military, showing that the XB-1 isn't just a passion project, it's the foundation for a multi-billion-dollar industry shift. Media coverage has exploded across platforms, with terms like the Concorde 2.0 and supersonic rebirth being thrown around. While some skepticism remains, especially regarding noise regulations and cost, there's no denying that the XB-1 has reignited global interest in breaking the sound barrier. The XB-1 is more than a jet, it's a declaration. That speed still matters, that innovation hasn't stalled, and that the future of aviation is brighter and faster than ever before. With the skies opening up once again to supersonic travel, one thing is clear: the age of slow flight is coming to an end. And at the front of this revolution is the XB-1, silent, sleek, and supersonically unstoppable. If this leap into the future of flight got your engines roaring, don't forget to like, share, and subscribe for more high-speed stories from the cutting edge of aviation. Because the next chapter, it's already breaking the sound barrier.